lot.
Gotcha.
So this is all I can find.
Sure. I have some RX bars.
I'll take one of those.
Okay. Let me review and I'll get it for you.
Awesome.
Okay. All right. So going back over what we've studied in the chapter so far, we started with like geometric mean.
Okay.
And remember, we might say we want to find the geometric mean between 2 and 12. And then we talked about proportions. And we said the geometric mean location is here and here. So then we turned around and we put the 2 in that spot and the 12 in this. These are called the extremas. These are the means. So what we did was we took that and just made that an x. Now this was applicable to the rest of the chapter, okay? Because then we started having theories that had to do with geometric mean.
Right.
So you're going to cross product. So you've got x squared is equal to 24. And then you're going to take the square root of both sides. And remember, I made you guys break this down.
So x
Danae was able to just give me a decimal value, but like that is 4 times 6. So it would be 2 on the square root of 6. Remember doing that? Okay. So that would be the geometric mean between those two things. Okay. That was the first section. Well, part of the first section. Then we had theorems that were based on that. And one of the theorem has to do with the altitude, and the other one has to do with the legs. Now, in these 2, or actually 3 theorems, if you will, the situation always has to be that you have a right triangle, and like the altitude has to be drawn from the right angle of a right triangle for this to be true.
Okay.
Okay? That separates then the hypotenuse into 2 parts. Let's say this part over here is 7 and this part here is 5. The theorem said the altitude, given these circumstances, is the geometric mean between the 2 parts of the hypotenuse. So the altitude, let's call it A. I'm going to put that in the geometric mean location.
Okay.
Okay, and it says the altitude is the geometric mean between the 2 parts of the hypotenuse, 7 and 5.
Mm-hmm.
Cross product, so I have a squared is equal to 35. So a is equal to the square root of 35. That really can't be broken out in 5 and 7. I can't get anywhere that way.
Yeah.
Okay, so that was one theorem we had. The other theorem had to do with the legs of the of a right triangle. Okay, so let's say x and y. So we found out that the leg is the geometric mean between the whole hypotenuse and the part of the hypotenuse closest to it. So let's say we're trying to find x.
Mm-hmm.
Okay, I'm going to put x in the geometric mean location. The whole hypotenuse would be 12, right?
Mm-hmm.
The part of the hypotenuse closest to the x is 7. Okay, so then it's 7, or x squared is equal to 84. And then I would take the square root of that. So that's going to be the square root of 4 times, and that might go in 4 and 21. Okay, so it would be 2 on the square root of 21. Okay, then the only thing that changes if you're trying to find y, the x of course changes to a y, and then that 7
is a 5.
Is a 5. Absolutely. Okay, remember doing all that?
Yeah.
Okay, that was the first section. The second section that we did had to do with Pythagorean theorem. Okay, you remember the Pythagorean theorem?
Yeah, it's like a squared equals b squared equals c squared.
Right, and it's always when you have a right triangle. You can't do it when you don't have a right triangle. Okay, so let's say this is 5 and this is 4, and I want to know that. Okay. I know the 2 legs. The legs are what forms the right angle. The hypotenuse is always the side opposite the right angle. So I would say 4 squared plus 5 squared is equal to c squared, or whatever you want to call it. So 16 plus 25 equals c squared. So that's going to give me a 41 is equal to c squared. So c is equal to square root of 41, which I can't do anything to.
Yep.
Okay, now sometimes, however, they might not give you the 2 legs. They might give you let's say that's 16, and this is 4, and I want to know what that is. Well, then I've got to go, okay, x squared, being my unknown, plus 4 squared is equal to 16 squared. So then I'm going to have to solve for the unknown. Okay, so x squared is equal to 16 squared minus, I don't know what 16 squared is, 256. So I've got 256 minus 16, so I have x squared is equal to 240. So x is going to be, and I'm trying to think of what to go into 240 that I can take the square root of. I know 4, you know, so I can go, oh, that's the square root of 4 times the square root of 60. But I'm going to be able to break down 60 as well, because I can do that, but then 60 is going to be 4 times the square root of 15. So the square root of 4 is 2. 2 times 2 is 4. So ultimately I have 4 on the square root of 15. Okay. All right. We also talked about they could give you 3 numbers, and they could ask you whether they were a Pythagorean triplet or not. And this is where your homework came in, if I remember right. Okay, so what we're going to do, I'll go over this, then I'll stop the video, and you and I will go over the homework, and then we'll pick back up. Okay? Like if I had 3 numbers, let's say I have 2, 4, and 7. To be a Pythagorean triplet, they have to be whole numbers, which they are, and they have to work in the Pythagorean theorem. So 2 squared is 4. 4 squared would be 16, and it would have to equal the largest one squared, which would be 49. That doesn't work. So that's not a Pythagorean triplet. Okay? So we did stuff on that. Now, you can have, they can give you numbers that work in the Pythagorean theorem, but they're not whole numbers. So they might be a right triangle, but they're not a Pythagorean triplet. Okay? All right, let me stop this.